Delivering powerful, scalable systems feels like a race. Much like the space races of the past, the race is more of a marathon than a sprint, with setbacks and victories along the way, both small and large. And as in the space race, the stakes are high. Our company's reputations and our own careers are on the line. So how do we scale our systems to an even larger scale, find stability, and achieve repeatable success, mission after mission? Strap in and join us as we explore the race to scale.
In this episode, we take a look at the workings of two teams, detail their missions, how they define scalability, their strategies, their technology choices, challenges, and successes.
My name is Graham Turner. I'm a senior site reliability engineer at Capital One, and I work with Cassandra on the customer platform here and some of the API layers to go along with it as well.
Hi, my name is Varun. I am a principal associate at Capital One, and I work on the Cassandra infrastructure in the customer platform at Capital One.
We're one of the nation's largest banks. We offer many traditional banking products as well as other online banking services. One unique thing about Capital One is that we recognized early on that the future winners in the banking industry were going to be great technology companies that still manage risk exceptionally well.
In the race to scale, who is the competition? And what does it mean to win? As often as not, the technical obstacles we face are a bigger daily concern than what the teams are doing. Each new technical milestone represents a new starting point for the next goal, the next mission. Most of the time, we're competing with ourselves.
Hi, this is Vincent. I'm a staff engineer in Intuit, working at the persistent store layer services for all developers in Intuit.
I'm Ben. I've been at Intuit for almost 5 years. I work on the persistence platform, and I've been handling a lot of the automation and infrastructure in AWS for the last several years after our transition away from physical hosted data centers.
Our largest customer in our platform currently today is TurboTax. We have on tax peak day about 300,000 concurrent users active in both regions in AWS, and we can support that in an active manner that's really incredible for our customers and also for our clients.
The race to scale is about how we meet our toughest demands. We work on systems where failure and downtime are unacceptable. To rise to these challenges, we need strategies and architectures that stand the test of time and allow for the flexibility to adapt to new circumstances. Many teams are exploring the idea of building a platform as a foundation for delivering new capabilities.
Our strategy in recent years has shifted to operating more like a technology company by integrating next generation applications as well as modern agile and DevOps practices into our daily lives. In 2015, where we announced at the AWS reInvent conference our intent to move out of our on-prem data centers and all the applications associated with that into the public cloud. And that was especially significant for the platform both Varun and I work on, known as the customer platform, as it sat in a mainframe in this on-prem system. The customer platform is integral to a number of the features at Capital One and sits at the core of the majority of it. Logging in, paying your bills, transferring money, and really anything that allows the customer to interact with their accounts and manage their money. So I think you could imagine this sees a boatload of read traffic, and prior to our DataStax migration, we had housed our solution in these on-prem mainframes, and that created some pain points around scalability and to-market speed. And as a result, as our business grew, so did these pain points, especially scalability.
A key factor in building these stable and reusable platforms is defining the success criteria upfront. Teams around the world are finding it important to define what scalability means in their unique situations.
Scalability for us means how can we better serve our customers? And with our previous mainframe solution, we did have limitations around space in the data center and licensing fees and a number of other things that just prevented us from bringing on new work intent. So at times we had to make really tough choices about what work we were going to groom going forward. And it sort of created a long backlog. And as one of those things got delayed, so did the others. And although this solution never really dictated the work we were doing, it really dictated how we were doing it and when we were doing it. So for some context, our batch jobs had to be run at night, and we couldn't send out a notification at peak traffic times. And we really had to think about what we were doing it because our mainframe capacity was really limited. So you could say our platform was really ready to invest in moving to the cloud and reap the benefits of on-demand scaling and the architectural designs of the cloud. But our real question here and the business problem we had was, how would we make this transition, and what technologies would we choose to do so? And we ended up choosing Cassandra.
As we've heard again and again, technical limitations with current systems often stand in the way of progress and our ability to achieve mission success. But the other factor in the race to scale that we can't ignore is time. Launch windows are finite. They don't remain open forever. Teams have found that platforms with well-defined interfaces are a launch pad for repeatable on-time delivery.
Our customer in this case is TurboTax, which we support. And they have a lot of microservices. They are stateless. And our platform basically taking care of all the headaches of managing a platform or managing the store, so that our clients, in this case TurboTax, only worry about their business logic. They never have to worry about how do we manage Cassandra, how is the data being encrypted, or how is it being stored, and what's the health of my cluster. All those are being taken care of by our team. The reason we created this platform is we realized that in the past we have a lot of people managing their data store, and not everybody is up to the task. Some do better than others. So what we provided is a uniform, easy to use REST API that our clients can use to bring value really to whatever product they're using, like TurboTax. Because in the end, it's the product that you want to focus on, not managing the data store. So our platform is, we manage all the data store, all the complication for you, so that our customer, our client, in this case, Intuit developers, can focus on developing their products and develop the greatest product they can, without getting to all the nitty-gritty every day of managing their own store. Scalability to us means that we can scale linearly. So for example, we have 10 times the customer coming in today now, then we can build out our Cassandra cluster, increase it by 10 times, and be able to meet the demand. Another part of scalability is to be able to meet the performance latency. We want to be able to have the same latency as we scale up. And another important part of scalability is resiliency. We don't want the system that can be tolerant to failure, because we are supporting very critical business function.
As our teams define it, scalability involves meeting not only the quantity of the demands on our system, but the variety of the new interactions required by our users. To achieve successful outcomes for customers and users, teams need to build that booster rocket that can deliver the critical payloads for each mission, and the technologies we select have an outsized impact on that delivery.
We wanted to invest in technology that is fault tolerant, distributed in nature, and also cloud native.
Our technical solutions, DSC Cassandra sits at the core. And then on top of that, we actually use Spring Boot APIs that are Dockerized and housed inside ECS in the AWS cloud. To go along with that, for our daily batch writes, we use Spark to handle those and a number of other validations to go along with that.
As we explored different technologies to support our modernization efforts, there were some key competency areas that we focused on, mainly heavy read support. Our customer platform needs to be relatively read intensive. We wanted to align on a solution that could support us with heavy read optimization. And it should be highly tolerant towards failures and minimize customer impact in the event of underlying hardware or infrastructure issues. And Cassandra, that we knew, is out of the box a write-heavy system. But we also knew that if tuned correctly, it would support our read-heavy use case. And we also wanted a system with batch and real-time availability, in the sense that our customer platform should be able to support a 24/7 real-time API infrastructure, but also it should enable us to parallelly run daily batch jobs which are read and write intensive. To run these batch jobs in our mainframe system, we had to run them only at certain off-peak hours. But with Cassandra, the ability to have different data centers in a cluster, we could run these jobs at any point in the day. So this is a big win for us.
Varun's emphasizing the fact that we are running these batches in a different data center than we are running our APIs. And so that allowed us, we were able to scale up with Cassandra and to be able to do that outside of like what we were doing before, where we were just running it on one system.
Distribution, redundancy, shifting, and separating workloads. These are architectural techniques that help mitigate and isolate failures and help teams build scale.
The stack for our persistence platform is largely based in EC2, entirely based in EC2, which is the compute platform in AWS. We have a humongous fleet of ephemeral app tier instances and hundreds of, not necessarily ephemeral, but the Cassandra nodes are, they are EC2 instances. So as far as how we expose our interface, some of our clients would dearly love to have direct access to a Cassandra port and just do SQL queries of their own. The persistence platform does not offer that. We have a RESTful API that stands in front of Cassandra where we store the metadata. We have on the order of 1/4 petabyte of metadata stored in Cassandra clusters across all of our different namespaces. The actual binary blob data is in S3, and there's multiple petabytes of that. Part of what it means to us to be a persistence platform is to offer our customers security and encryption and identity management and namespacing and all kinds of other features that now they don't have to worry about. They just have a RESTful interface to interact with. So that's what we provide. We have leveraged our Cassandra and more specifically our Cassandra automation expertise to create sort of a set of best practice recipes in third-party tools wrapped together by scripting that is becoming kind of a de facto standard in Intuit. There's around half a dozen teams now onboarding and using this to deploy and manage their DataStax clusters.
Many teams have gained leverage and increased productivity by defining reusable components with simple, well-defined interfaces. This enables the swapping in and out of components and allows the team to work on separate concerns in parallel to achieve scale more rapidly. Once you've developed a stable platform, you must put it to work. Scaling out is a process that requires careful execution at each stage in the mission.
Our journey to the cloud didn't happen overnight, so we didn't suddenly wake up to a fully scaled system servicing billions of requests daily. Instead, we embarked on a multi-monthly journey where we planned careful migration waves and also planned deep data integrity validations. And our main focus was to approach this entire migration with a risk-based approach. We want to gradually enable customers onto this new platform with making sure that they have zero service disruptions throughout the entire journey. And we had the main tenets for this migration was phased deliberate migration waves and backward compatibility and deep data integrity validations. With migration waves, our approach was to enable customers as waves so that we start with internal associates and then we move from less complex to more complex associates. And with backward service compatibility, the new features that we built, we made sure that they're backward compatible for parity for customer experience. And with deep data integrity validations, apart from the data model differences, we wanted to make sure the data in the new and the old systems remains the same. And we invested more time in creating tools that would help us in real time comparisons of API responses, and bulk data reconciliation.
When you've designed for scale, you expect challenges in flight and are equipped to diagnose and mitigate each risk as it arises in real time. But even with the best efforts, design flaws can emerge at interfaces that are experiencing high stress.
The issue started happening one day when we run our daily batch job. So we run this job every day to ingest files into our system, and we run this job only on our analytics data center. So when we on that day when we ran the job, we saw that there was like a high CPU on some certain nodes on both the analytical data center and both the transactional data center. So we didn't know what was happening. Like, is there something wrong with a particular partition? So when we investigated it more, we found out that in a table, the UDT column, which is a nested list UDT, was having a lot of items in it. So it was one of the corner cases with our batch application where we try to add more items into a particular partitions column, and we add and we keep on appending data into that particular column. So this was causing a lot of heap pressure onto the nodes, which kind of replicated to the same nodes in the other data center. And we had to manually intervene and delete that particular partition to make sure that we mitigate the issue. And also we made a fix on the batch application side to catch this particular corner case.
In retrospect, we definitely could have denormalized our data model a bit more, and running into this issue was a good lesson learned for our project in general. And although we were able to work around it and actually still have a very successful migration with this data model, we definitely saw this as a lesson learned and something we could have done differently.
Careful monitoring of each component in the system allows for early detection of potential problems and the ability to deliver targeted mitigations before the mission is at risk. But how do you continue to deliver consistent performance again and again, mission after mission? Many teams are looking at automation as a key part of this solution.
Several years ago, when we started transitioning from data centers into AWS, we had the need for an automation framework. So we created one more or less from scratch. We opted to use third-party tools because we felt that would be more portable as we moved potentially out of AWS and into a different cloud provider entirely. And also we thought that there might be more relevant skill sets involved in learning tools like Packer and Terraform as opposed to cloud-native solutions like CloudFormation. So that's what we did. We have a whole suite of Cassandra deployment and management tools using those third-party orchestration frameworks and configuration engines, Packer and Terraform and Ansible and Jenkins, and but it's extensible and modular. Again, we could move to the Google Cloud or Azure or anything else and continue to use the same framework.
As we've learned from technology races of the past, the human race achieves the most success when we innovate on core technologies together in open communities. This allows for each team to focus on their unique mission.
We are really happy with the open source Cassandra community. Whenever we have any questions, we go to the Cassandra mailing list, both for the developers and the administrators. So we try to see if the questions that we have been answered in already emails, or whenever we send an email, there was a lot of times that when Jonathan Haddad replied to our emails, and in the open source Slack channels, like whenever we have any questions, we just type our questions in them and we can see the response immediately. And there was like a lot of videos on YouTube that we could refer to, like the DataStax Summit videos, which are very helpful. And also like a lot of Medium blog posts that we always read, and Stack Overflow questions that we always refer to for our questions.
My main learning from this whole process has been actually to lean on that expertise. There's a lot of Cassandra experts at Intuit. I'm not a Cassandra expert. I have some expertise in the realm of Terraform and automation and baking AMIs and getting stuff running. But as for people come to me and say, how do I disable this particular feature or enable this particular feature, or I need you to poke a hole in this automation for me to let me add this parameter, and I just, okay, sure. They know what they need, and I'm just here to help them. But when someone else comes to me with a problem regarding Cassandra, something I can't answer, I now have a little community to point them to and say, look, there's people here at Intuit that have this exact same problem, and we solved it last week. So go take a look.
Our participation in open communities starts with asking questions and receiving knowledge. But teams take their interactions to the next level and gain industry leadership. They start contributing back to the community by sharing technology that can help others in whatever race that they're in.
We chose to begin the open sourcing process for the framework of automation tools we have put together because there's just nothing in the market right now like this. And I was taught that by how quickly it's being adopted within Intuit. We inner sourced it, so to speak, by making it available to everyone else at Intuit. So we were working on open sourcing this, and I think it fills a sort of a void right now in the market.
After countless hours of research and development, production, and operations, many teams reach that coveted position of mission success and take the opportunity to celebrate and recognize what they've accomplished.
So there have been a number of successes, and we are just very proud of the system we have in production today. We're just in a much better spot than we were pre-cloud and pre-DSC migration. And we could talk about a number of them, but we'll go into three. So one, our architecture style is now active-active compared to active-passive. We're multi-master as well, and this has helped us achieve 5 nines of availability and durability, which has just led to a much better client experience. Our second point is that our latency across the board has decreased by over 50%. And that leads to a better upstream experience from our internal clients and an overall better client experience. 3, we are in a much better position to deal with something like disaster recovery. And that could be a data center outage or a regional failure. And we internally in Capital One actually go through a number of these practices. And it's a lot easier to get through them all with our Cassandra solution compared to our mainframe solution. So we're meeting our SLAs. We're positioned much better to deal with disaster scenarios, and our quality of our system is just leagues more advanced.
Scaling up and down with Cassandra in AWS has been really great, and that's because we have matured in our automation through these 9 years of journey with Cassandra. We have been Cassandra user for 9 years in production. We have a lot of learnings along the way. In the beginning, we were in our own Intuit data center. Our automation was not there. So managing Cassandra without the right automation brings a lot of challenges. But as we moved to AWS about 4 or 5 years ago, we had to automate everything. We were forced to. There's no choice. To what we have today now, our Cassandra deployment now is a breeze. It's like a walk in the park now.
As we've all experienced, celebrating success is important, but those who stop pursuing innovation will soon be surpassed and survive only in historical footnotes. The most successful teams use lessons learned and the technology foundation of previous missions for the next challenge. What about your team? Are you ready for the next stage in the race to scale?